Good morning once again. My name is Brian Theory. I'm the Director of Strategic Engagement here at ReliabilityFirst. Thank you so much for coming out to our annual summit. It's always great to see everyone. I apologize that our President and CEO, Tim Gallagher, was supposed to be here today. Unfortunately, he had a family emergency. He was going to be the one moderating this panel, so I'm going to do the best I can up here to fill in for him. So please keep him in your thoughts and prayers. Also, Paul Siegel was supposed to be here today. He let me know very late yesterday that he was very sick as well. So very nice picture of him up there, but he will not be on stage today as well. However, we still have a distinguished panel of presidents and CEOs today here to share their vision of what the grid of the future looks like and how we are going to meet today's and tomorrow's challenges. Varying viewpoints are not only anticipated, but encouraged. If there was an easy solution, these conversations wouldn't be needed and we wouldn't be having this panel. When I was at NCSL just a couple of weeks ago, I heard a statement and it resonated with me. It said, differences of opinion are not differences of principle. And I can reassure you that everyone on today's panel is committed to electric grid reliability and security. As Michelle mentioned, in the digital program on the link tree, there is a biography for each panelist. And in just a minute, they will be given an opportunity to introduce themselves and tell you a little bit about themselves and their company and their role. However, before we get started, I am going to provide a brief overview of the NERC and ReliabilityFirst perspective so that the panelists have more time to talk about the potential solutions. At ReliabilityFirst, we perform studies and risk assessments. However, we cannot mandate the construction of transmission or generation. It is our responsibility, however, to identify and communicate these risks broadly to the industry and the policymakers so that they can address them. So, what are the risks that we are seeing? Actually, there's a really great summary in the very recent NERC risk report. If you Google it, it's the RISC risk report. It's published. You can read it online. However, I will provide a summary. We here at ReliabilityFirst have been communicating over the last 5 years that the grid is changing. We have been removing and retiring thermal generation, primarily coal, due to a combination of market and policy reasons. In the interconnection queue and being installed is primarily inverter-based resources. In fact, in our regions in the Midwest and Mid-Atlantic, it has been primarily wind and solar with very little battery storage. You have probably heard a lot in the past year about the unprecedented load growth. Load growth has been somewhat flat over the past decade, but now we are seeing a growth rate of 4 to 5 times what we've been seeing recently. This is primarily driven in our region by data center load growth, but it can also be other industries, heat pumps, electric vehicles, mining, even cryptocurrency. We will be talking with our panelists today about these projections and what they're seeing. Even before the load growth projections, the NERC LTRA, the long-term reliability assessment, coinciding with PGM and MISO reports, were identifying potential resource adequacy shortfalls around the end of the decade. The load growth has only been an accelerant. The new resources that are being added to this system are not coming on fast enough, and they inherently work different than the resources we've had in the past. They are weather dependent and do not yet provide the same essential reliability services. These challenges are being addressed through battery storage, FERC Order 901, plus technologies such as grid-forming inverters. However, as we learn more and more about these risks, we study the energy transition across the globe in countries like Germany, Sri Lanka, plus we continue to analyze the recent blackout that impacted the Iberian Peninsula this past April. We have experienced extreme weather events in our own region that have challenged reliability and brought a focus on natural gas-electric coordination. NERC has an excellent Reliability Insights article that was published earlier this year that details Winter Storm Enzo and how that event may look in the future if we continue down the same path. I encourage you to check that out. Layered on top of all these risks is the ever-present cyber and physical security challenges that we face. And we are very fortunate today to have Joe McClelland from FERC on today's panel to touch on these security risks, including all the associated risks we have with the AI arms race related to the data center load growth. Speaking of security, we have supply chain risks, which include not just access to the pieces, parts, and labor needed to build the grid of the future, but also questions about where the materials are coming from and what vulnerabilities may be in the hardware and software that we purchase. But as Jim Robb will tell you in this afternoon's fireside chat, other than that, everything is going great. At this point, it is my honor to introduce our panelists, and they can provide their perspective on how we meet these challenges together. So we could start with Christine Martin from PPL. Please introduce yourself, your company, and just a high-level overview of your company's role in the ecosystem.
Good morning, everyone. Thanks for having me here. I appreciate it. So Christine Martin, I am the president of PPL Electric Utilities. We are an investor-owned utility transmission and distribution headquartered in Allentown, Pennsylvania. We cover a 29-county service territory, so 10,000 square miles in Pennsylvania with 1.5 million customers, 50,000 miles of transmission and distribution lines. So I like to say it's, we can circle the world twice with our grid infrastructure and, of course, a number of substations that come along with that. From a transmission level, it's about 5,500 or just under 6,000 of those miles, so very large distribution system in that footprint. So PPL Electric Utilities is one of 4 utilities of PPL Corporation, which is also headquartered in Allentown. I like many times being adjacent to the corporation. Sometimes it works for me. Sometimes I'm the one who has a little more challenges than my peers in Rhode Island and Kentucky. But we've got a nice portfolio of regulated utilities, gas and electric in Rhode Island under Rhode Island Energy, and Kentucky Utilities in Louisville Gas and Electric, generation, gas distribution, and electric in Kentucky. Obviously a transmission owner in PJM and very engaged in all of the issues that you just heard about, so happy to be here.
Good morning. Bill Fehrman with American Electric Power. Been in this business now. This is my 44th year of doing this. Seen a lot of change throughout that period of time. Currently president and CEO of American Electric Power. Just prior to that, I spent nearly 18 years with Berkshire Hathaway Energy, and then prior to that, 25 years with Nebraska Public Power District. So very much have this in my blood. I recently retired in October of 23 and then saw the amazing things that were happening in the industry, and in particular, the opportunity for advanced nuclear expansion in this country. And so had the opportunity to join AEP back in August of last year, and have had a great time since becoming a part of that team. AEP, for those of you who don't know, is active in 11 states. We have the largest transmission system consisting of 765 kV in the country. Very active in all of the RTOs other than the west side. Very active in working through a number of the generation issues that are impeding our ability to add load, particularly in PJM and SPP, and look forward to the discussion here today.
Good morning. I'm Todd Snitchler. I'm the president and CEO of the Electric Power Supply Association, or EPSA, as we're more commonly referred to. EPSA is the only national trade association that represents competitive wholesale power suppliers, and our members own and operate about 205,000 megawatts of generation in all the markets around the country, from California to Texas to PJM to New York to New England. And they still operate and own all types of resources, so natural gas, nuclear, coal, hydro, battery storage, renewables. If it makes electrons, our members own and operate it in the various parts of the country. Of course, my background, I've been in this role now for a little over 6 years, but I come at this, I'm the triple threat, I suppose. I'm a recovering lawyer, I'm a recovering regulator, and I'm a recovering legislator. And so I try to wear all 3 hats in a way that is helpful when it comes to policy development and advocacy. And so I was the chair of the Ohio Public Utilities Commission. I worked for API before I came to this role, so I understand the natural gas portfolio a bit. And much like my counterparts on the panel, EPSA's primary goal, of course, is to ensure system reliability. That's table stakes. Everybody agrees that that's where we need to start from. We have a difference of opinion, perhaps, on how we achieve that reliability. But I think, to Brian's comment at the outset, there are differences of opinion, but I think fundamentally we all agree that that's the primary obligation for the generation side as well as the wire side. So I look forward to the conversation.
Good morning. I'm Joe McClelland. I'm the Director of the Office of Energy Infrastructure Security at FERC. Our office was stood up to work collaboratively with the industry, with states and other federal agencies. Our engagement is with the most advanced adversaries that you'll face on both the cyber and physical security side. So we're at the nation state level. All of our folks are engineers or cybersecurity specialists. We all hold high-level security clearances. Prior to that assignment, I was the first director, also the first director of the Office of Electric Reliability, and I'm sure you're all familiar with that office. We stood up the approval process, the review and approval process for the ERO as well as for their standards. Prior to that, I spent 20 years in the industry. I was at Custer Public Power District. I was the general manager in Nebraska where I met Bill Fehrman. He was my G&T. And prior to that, I spent the majority of my private sector career at Allegheny Energy in a variety of roles. Thank you for the invitation to be here today.
Thank you all. So we are going to jump right into the question that you've heard asked at OPSI, OMS, MACRUC, MARC, NARUC. It's the question on everybody's mind. It's on resource adequacy and load flexibility. So as we plan for the reliability in the face of significant load growth and shrinking supply margins, what tools do we have and how can they be utilized to most effectively manage these challenges? And for this question, we're going to start with Christine Martin from PPL.
Simple question, right?
Very simple. Yes.
No, it's an excellent question to kick off the panel because obviously there's a lot of opportunities in front of us, and kind of we think about the challenges that Brian you went through. Sometimes it can almost feel a bit crushing, but like the gentleman to my left, I've been in and around electricity, energy, infrastructure policy for close to 30 years, and we've had times in our history where issues or problems seem insurmountable. I would say the one that's in front of us is probably a collection of factors that I don't think any of us could have predicted. But I do think even with all those challenges, there are, of course, a lot of opportunities, and it gives us space for innovation and collaboration. I was thinking about this question, obviously a bit as we talked, but it's something that's constantly on our minds, everybody in this room. And I spent some time at PPL Corporation as the Chief Sustainability Officer, working across our operations, but pretty extensively with our Kentucky generation portfolio at a time when there was significant investor and policymaker pressure, at least outside of Kentucky, on decarbonization and really, really pushing on utility IRPs and perhaps kind of stretching those portfolios beyond where we could go from a customer standpoint, an affordability standpoint, and a reliability standpoint. But one of my mentors taught me something very early on that kind of was with me, and I think helped in terms of how it guided our approach, which may have not gone as far as some may have wanted us to, but in retrospect, I think was the right approach, which was really looking at where can we go with innovation? What is the right diversification, because you always want diversification in your portfolio, whether you're talking about generation or regulated transmission and distribution or what have you. And what's the capability of the technology and the resources in front of you? And it needs to work together as a system. So as we think about, even kind of what you see up here, generation, transmission, distribution, our customers, our technology, AI, data centers, manufacturers, renewables, and other services, it's got to work together as a system. And that is the approach from which I am going to answer this question. And I would just say that anytime that you are kind of putting your finger too much on the scale, policymaker, company, on a technology or resource and stretching it well beyond its intended resource and capabilities, that system's getting out of balance, right? And what can suffer from that is reliability, resiliency, and affordability. So thinking about this question, I'm gonna touch on kind of three buckets. The first being generation, right? We need generation. We need more of it. Full stop. It is very likely that dispatchable baseload generation is going to need to be around for longer, as we're seeing those plants that may have been intended for retirement for various reasons are being ordered to stay around for longer. Those plants, despite how you may feel about environmental concerns, those plants add a lot of value to the system in terms of strong baseload generation, attributes that they provide to system operators in terms of inertia on the system. And quite frankly, we need more of that. We need more or net new baseload generation. That makes room for things like renewables in the system and storage on the system. You can't have that out of balance. So there's some things obviously that we've seen in PJM in particular that have been done to try to bring new baseload generation to clear out the queue. Obviously, we had the RRI process where we saw, I think it was about 11,000 megawatts. I would love it to be gigawatts, 11,000 megawatts that were unlocked through that process. It took a lot, though. It took, I think, more than 50 projects for that to happen. It kind of just, I think, gives a sense of the scope of, how much generation, how many projects might be needed to fill the gaps that we currently have. So I think we need to see more of that in terms of getting shovel-ready projects through that queue. Looking at permitting, both at the federal level and the state level. Local issues, both from a generation standpoint and a transmission standpoint, can be challenges as well from a siting and permitting standpoint. But I do think that we've seen when we have good state coordination, that generally, and good state policy, that generally will at least help assist with some of the local issues. Look, we've also been really vocal. I've been very vocal as PPL in that utility regulated generation should be an option, perhaps where it isn't now, as a backstop, not necessarily as the first order, but where the market cannot deliver or is not properly incented to deliver, that we ought to be looking at regulated utility generation as a backstop from a reliability and resiliency standpoint. But clearly we need more. Let's talk a bit about transmission. So I think from a transmission standpoint, I think that the transmission grid as a backbone is going to play an increasingly important role, not just in energy reliability, but in energy assurance. And actually, just kind of backing up for a moment, connecting generation and transmission. We talk about reliability and meeting peak loads and planning expectations around loss of energy to meet peak load. But as we think about our system, increased electrification, onshoring manufacturing, data centers that are adding to both peak load, but also are requiring 24/7 reliability and resiliency. We have processes that are much more sensitive to fluctuations in electricity. We've all heard the 5 nines, right? The 99.999% reliability that we hear from AI and data centers. That's more than just meeting peak load. That is energy assurance. Not only do you have enough megawatts, but are those megawatts dispatchable when you need them? So I think from connecting the transmission and the generation systems, I think that view on energy assurance is going to need to be, I think, at least on an equal footing in our planning and our operations in terms of kind of how we look at system peak demand and energy assurance. On the transmission system, look, we need to continue to make the basic upgrades in system hardening and reliability, but we also need to look at what is the ability to unlock capacity on the transmission system. So we have at PPL used dynamic line rating. We've deployed it on 11 of our lines. currently, that is a pretty efficient and economic way to unlock capacity on the system. It also gives the system operators good visibility into current conditions on the grid. We've been successful at working with PJM and being able to provide that real-time information to the day-ahead market, so it's actionable. I think we need to see more of that use of grid-enhancing technologies across the industry from a capacity and flexibility standpoint. I think batteries as a transmission asset are also important for us to consider. That's something that I think we're not, I think that AEP attempted, I think that we're not doing that more broadly across the system. We are at the distribution level. I think that's something we can also bring to the transmission level. And then finally, what I would call kind of the icing on the cake. So the generation is certainly the base of that cake in the transmission grid. The icing on the cake is really the other resources of demand response and load flexibility. They are not a replacement for generation. They are not a replacement for transmission, but they are an important, and I think going to be an integral component, an increasing component of our grid from an energy assurance standpoint. Questions, I guess, that I would pose, or thoughts around load flexibility and demand response. So PJM took some actions, I think, that will be in the next auction in terms of the contributions of demand response and kind of how they can be incented in the market. I think we need to continue to look at wholesale changes, also the intersection between wholesale and retail and how we are incentivizing demand response. What the capabilities are for load flexibility. I think it's not so much a technology issue, but really working with our customers, particularly our large load customers, to understand really what is that flexibility, not theoretical, but actionable. Again, those resources are only as good as they can perform in the market. So will they be there when we call upon them? As the system, as we experience multi-day weather events, whether summer or winter, can we rely on demand response and load flexibility kind of over and over again in a multi-day event? Not saying that we can't or we can, but I think those are questions that need to be answered and worked on by a number of stakeholders. I'll leave kind of that collaboration with an approach that EPRI is taking right now, EPRI's DC Flex initiative. We and I think about 44 other partners, that's utilities and hyperscalers, technology companies, policymakers, are part of an initiative to look at these types of questions with our largest hyperscalers. What are the opportunities for load flexibility? What are the operational efficiencies? How can data centers be designed in ways that give them more operational efficiency? HVAC and cooling, I mean, we think about kind of the computing, but there are systems that support that infrastructure. What's the flexibility there? What's the flexibility with backup generation? Does it all have to be diesel generators, which can be limited by local air permits? What are the opportunities for battery storage or other technologies, whether it's gas? I hesitate to say nuclear, but I think we're probably going to have to use that word at some point on this panel. Maybe not so much for backup generation, but as additive to the broader resource mix. So again, I think that icing on the cake is probably something that we need to talk more about and how it can be part of the whole. So let me pause there.
Thank you, Christine. I've been doing state outreach now for about 3 years, and that was probably the most thorough answer I've ever heard. Thank you. I wish I had a pen. I was trying to keep track of everything. Yes. Fantastic. So I'm going to pull on a couple of threads here. You led with innovation. And I love the innovation because I read as many reports as I can. Everything from what's possible to what's probable to what's coming to what's 5 years away to what's 2 years away. Everything from SMRs to the NREL, the National Renewables Lab. They talk about, EV to grid, plugging in your electric vehicle to power up the grid, virtual power plants in Maryland and Delaware, fusion systems. I hear about all these great innovations and these technologies that may be part of the grid of the future. Yet when I look at the interconnection queue, it's still primarily wind, solar, maybe a little bit of gas. So how do we get, and the other panelists could chime in as well, how do we get from that innovation stage on paper to in the queue, on the system, ready to go, and how far away are these things? And anyone could chime in.
I uncrossed my leg first, Bill, so I'll go first, and then I'll hand it back to you because I think I know what you want to talk about. So we did really well, Christine, for most of your comments. I agree with almost all of it. Most people probably do. I will say we share the desire for innovation because innovation is how we're going to solve a lot of these issues. And innovation isn't merely in the generation space. It's not merely in the transmission or distribution space. It's the entire system. And I think I like the collaborative nature of how we're going to try and address some of these because you can look at the situation we're in from two perspectives. One of which is these are almost insurmountable challenges. We're going to struggle to keep the lights on. There's no way we're going to be able to accomplish all the things that we can accomplish. The other way, and the way I prefer to look at it, is these are opportunities for the engineers and the operators and the owners of facilities to do what they have done for the last 100 years or more, which is deliver reliable power to consumers. It's not easy. It's probably not inexpensive. And we have been in an era where prices have been pretty low. We were talking at dinner last night. You know, the price that somebody paid for their electric bill is only what they paid last month. They never look back beyond 30 days. And so when you tell them the price is going to have to go up because there's investment that needs to be made on the generation side, on the transmission, on the distribution side, there's really almost nowhere for prices to go but up. So then how do we innovate our way to the least impactful increases to consumer bills? And where do they see the value in what they're getting as part of the system? I mean, bills are relatively flat year over year with some modest increase. The component parts have changed over the last 10 years, but they're not really as high as some might feel that they are, but that's what's driving political solutions, which is not an innovation I think we want to lean into. In fact, less politics probably leads to better engineering outcomes, says the lawyer and the recovering legislator. You don't want the government picking winners and losers. I want to trust my engineers that can figure out how to do it. But how do we get there from here is really the question. So I think we have to deploy everything we have all the time, all at once. It's that movie that my son insists that I should watch that I've still not seen. But at the end of the day, it means we're going to have to, I've tried to break it down into 3 blocks. We've got an immediate problem, 0 to 5 years. So between now and 2030, we've got some issues that have to be addressed, like load growth that we haven't experienced in 20 years or more. How do we get over the hurdle there and get things constructed? To Christine's point, that we've had some challenges with the interconnection queue, but largely they have been addressed. Things have been pushed through the queue. I think PJM's number is 46,000 megawatts have been put through the queue and are now have signed ISAs, and we're waiting for whatever the next hurdle that they have to overcome is, whether it's permitting and siting, labor, supply chain, what have you. There are thousands of megawatts that are through the system and have yet to be interconnected. We've got to solve that problem. I think you've got a second 5-year problem or challenge, which is, let's assume we get through 2030. Then it's what are the technologies that can be deployed 2031 to 2035 or 36 that are going to really help us get through the difficult period of rapid load growth and kind of have that sustainable period forward. And that's where things like longer term solutions of maybe new nuclear or small modular reactors or new technologies that somebody's trying to figure out in their garage that haven't yet been made available are likely to be deployable. I don't know that they're deployable in the next 5 years, but that doesn't mean there aren't solutions that are available. So how do we sort through the interconnection queue process? How do we solve supply chain? Is it reshoring of manufacturing? And oh, by the way, let's assume we have all the equipment we need. If you don't have a trained workforce that can actually install it, Christine's company wants to have it, Bill's company wants to have it, our members want to have it, and so do the data centers, and so do people that are building factories. So you have got thousands of projects that have a very limited pool of skilled labor. We've got to grow that pool of skilled labor if we're going to solve the issues. So it's really multifaceted. There are going to have to be ways that we think about this differently than we've done it in the past. So it won't surprise you to hear somebody who represents competitive wholesale suppliers say, if you have the market send appropriate signals and depoliticize the process, you are going to see the investment you want to see. Christine noted the RRI outcome was 11,000 megawatts. Predominantly, those were projects that are owned, operated, or being developed by competitive suppliers. And so they have responded to what is, to be fair, a muddled market design that is trying to get itself resolved, but still saw 11,000 megawatts of new resources commit to try to come on the system by 2030. That shows that there is capital ready to be deployed. It simply needs an appropriate price signal that will allow it to do that. And I think having PJM get a little more certainty around the parameters will help us achieve that. And clearly, Christine noted, and this is where our one point of disagreement might be, is that there ought to be a utility-owned or rate-based backstop, and we would disagree with that because utilities already typically have an unregulated affiliate that is able to build generation now. And if the situation is as dire as we think it is, where there's a need for new resources, then the capital would be available in a competitive affiliate to be able to deliver those resources as well. So there is no need to go back to the model that we have spent 20 years moving into a restructured model to then say, well, but we want to keep, we want to be a little bit pregnant. That generally doesn't work out very well. And so following that path forward with appropriate price signals and allowing our friends on the T&D side to innovate and invest in technologies that will help deliver the electrons and incent the generators to produce the electrons is how we're going to solve the problem in a way that is most cost beneficial to consumers.
Okay, so I'm the referee. So it's interesting. Todd mentioned 11,000 megawatts. To give you a sense of what that means, the AEP load today is about 38,000 megawatts, which took 100 years to get there. We have 24,000 megawatts of signed agreements for load that we're bringing on our system. That's just AEP. So we absorb the 11,000 very easily. We need 13,000 more. We have 190,000 megawatts who wish to interconnect into our system over the next 5 years. So put that into perspective where we're up here talking about trying to get 5,000 megawatts here or 10,000 megawatts there. We need 190,000 megawatts to connect the customers that we have. And I would say that it's imperative that we get that connected because that is the fuel for combating China and combating the AI race that we have in front of us. It's a national security matter. It's a customer matter. And it has to get solved. And so for us, I've never been in a more exciting time in this business. I tell our team that our focus is on delivering for these customers and delivering for our country. And that through the great collaboration we have with ReliabilityFirst and in particular Jim Robb and NERC and his team to where we can have good, candid discussions around what the challenges are and how we need to face them and how we need to resolve them. That's going to allow us to move quicker. But while I'm excited about innovation, I'm excited about what might come, my focus is on the here and now, which is we need to find every megawatt we can get. We need to get it on the grid and we need to get it operating and we need to get the customers moving. And so our purpose is to jump every hurdle we can to figure out how we get as much on the system as we possibly can. And if you're an engineer or you love this kind of business, now is the best time ever that I've been around to be in this business. And it's all possible. It's been an incredible journey over the last 4.5 decades for myself to see the challenges that have been overcome, and this challenge can be overcome. But we're not going to be able to do it in the way that we've always approached it, which is fill out an IRP, wait for 2 years, get it approved, go find a turbine, stick it in the ground. That's not going to work. Like, we need to figure out how to fix PJM. My colleagues seem to think it's working. I would say it's broke as hell. It needs to get a dramatic turnaround. I would say the same thing about SPP, that they have to figure out how to allow us to get more generation in the ground and get it in fast, and figure out how we can get transmission approved and sited and get it in fast. Because this isn't a 10-year or 20-year issue. This is a 5-year issue. And it may be a 2-year issue if the Taiwan-China issue explodes like people have talked about over the next 24 months. So I would say there's an inherent need for efficiency and speed in all of this, while we maintain reliability, which is obviously front and center, but we're going to have to think about things differently, and we're going to have to be driven to deliver, and that's essentially the message to my team at AEP.
Bill, if I can just add, those numbers are astounding. Let me just share with you, in that service territory that I mentioned, that 10,000 square mile, 29 county service territory in Pennsylvania, our system peak is about 7,800 megawatts. We actually created, it was a new system peak just this winter. It took us 100 years to get to that peak. And our data center load in advanced stages, so this isn't everyone who's inquired to connect, that's like 50,000 megawatts. The load in advanced stages is 14,400 megawatts. So that is just about double the current load we have. So when I talk about getting generation on the grid, siting transmission, creating space and capacity, it's from that perspective. This is, we've got an obligation to deliver for our customers. And so this isn't when I talk about generation, for example, this isn't that there's a lack of IPPs. There is a pie that is getting bigger and bigger in constraints that we have in getting necessary generation and infrastructure built. And so when we approach this as a backstop, it's something different. It's not looking at adding to resources that already exist in terms of companies that already exist or deploying capital in that same way. It's really looking at this differently and from a perspective of, are we going to have enough when we need it? We are currently in Pennsylvania a net generation exporter, but again, looking at that zone, which is in, for those of you, we're all right, we all care about reliability here, so we all know how load shed works. We know about reliability zones. You take a PPL Electric Utilities and a PECO and a Maryland and a Delaware and a southern New Jersey and DC, and we're all in the soup together. And so for my friends in those states that are receiving exports from our service territory, when you hear my peak load is 7,800 megawatts, and my advanced queue is 14.4, you should be concerned.
Just one data point, Joe. I swear you will get a chance to say something. So
It's fine.
the only thing that I would add, and I agree with my counterparts, the load growth numbers are stunning. You have to keep in mind there is, however, a ceiling on how quickly and how much can be added, because there is currently a limit on the amount of chips that are actually available. So I can announce a project and say that I'm going to build a data center and it's going to require a gigawatt of load, and all that's true. But unless and until I can get the chips that you need to power the data center, it's not going to come online. So we just need to make sure that we are accurately forecasting both the pace and rate of additions to the system, because that helps inform exactly how quickly and how much needs to come on the system by when. It's not that we don't have a problem or a challenge that comes with load growth. We do. It is coming, and I agree. We need more resources. But I think we need to just have a little bit of caution about how quickly, because of the actual availability of the technology that will be available to fulfill all of those commitments that entities have made to say they want to add new resources to the system. So it's not a criticism. It's just a observation about, we do have some bounds around availability and when you'll be able to put those resources on the system that I think we have to include in that discussion.
Okay, so it's my turn now. So I'll note one thing, that as the only government guy on the panel, I am required to give a disclaimer before I give remarks. And I have an attorney here today that's watching my every move, Robert. So my grandfather used to say, I feel like the petunia in the onion patch here. But in any event, the views I'm about to express are not necessarily the views of the chairman, any commissioner, and the commission itself. And in the event I say something really bad here today, they're not necessarily my views either. So just a few quick items. And I mean, we've had some really great comments already, just tremendous. There's an additional consideration in that we have an unprecedented amount of generation retiring at the same time. So at the same time, we have this unprecedented need for generation. We've got baseload generation that now is retiring en masse on the grid. We also have the president's executive order where he declared a national energy emergency. And he said a sufficient supply of energy, and noting that artificial intelligence and data centers, they're a matter of national security. These facilities have to be located on U.S. soil. They have to be. And we'll talk a little bit about that as we move forward. But we're facing these challenges. Now, the Commission has taken some action, the action within its own authorities. We've issued Order 2023. We've issued Order 1920B. We've approved PJM, MISO, and SPP interim actions. These are small actions, but they're intended to help clear the interconnection queue, expedite the study process, and prioritize resources, for reliability purposes, the critical reliability projects. I just want to say again that back to the issue itself, and again, we will cover this in more detail. We're seeing a convergence. It's like Bill said, I've been an engineer, electrical engineer in the business for over 40 years. I've never seen a more exciting time. We're actually seeing a paradigm shift. So we're seeing a convergence between big data, artificial intelligence, and quantum computing. And we're seeing that now applied to everyday life as well as national security. And if these data centers and these artificial intelligence centers and soon to be quantum computing facilities, if they aren't located on U.S. soil, there will be a no second chance. So I wanted to throw that out to sort of cheer up everyone's morning to start with. But I'll have additional comments as we move forward. Thank you.
Thank you, Joe. And you just mentioned the generation retirements. I do want to circle back to a point Todd made, is that, he brought up the market signals and then the cost. And despite the capacity auctions and the prices going up, there has still been two, we call them 202C orders, where there's been two power plants, one in Christine's home state of Pennsylvania, the Eddystone plant, and one in MISO, the J.H. Campbell plant, that had been ordered to not retire, and they were kept online for 90 days. And 90 days later, they were asked to stay online for another 90 days for reliability purposes and for, winning this, AI arms race and for our energy abundance and for all those things. However, Todd, how do you reconcile that with the market signals? Because the prices are going up. That's supposed to incentivize generation from not retiring. But here it is, and it's kept online. And where does this, I'll call it this vicious cycle of retirements, where does it end? Knowing that these plants can't stay on forever.
Yeah, thanks, Brian. First, I'd say the challenge of running a plant 90 days at a time, I'll defer to the operators to the table, but that's not a workable business model, period, full stop. So I think the second part of that, and the more direct answer to your question, is we have already started to see retirement announcements be withdrawn. We have seen delays to retirement announcements because the price signals are both indicating that the resources are needed and are being compensated in a way that will keep them around. And secondly, we're seeing an increase in demand that says these resources are also needed. And so keeping them around is exactly what the market would want us to do. You have looked at 3 consecutive years before the first increased auction in PJM where you had year-over-year record low prices for capacity, which was doing exactly what the market would say, which is exit the system. Now you see prices finally increasing, which is reversing that 3, or really it's a 5-year decline, but 3 pretty dramatic years, which is saying, no, we need to retain what we've got, and by the way, we need to add new resources. And so that takes time. I mean, I would love to say we can stand up a plant, and I don't care if it's a utility-owned plant or it's a competitive generator, you can't build a power plant in 2 or 3 years anymore. That's just not doable. So there's going to be a period of where we need these gap fillers, delayed retirements, incremental increases, resources that can be added to the system that will get us to the point where those new plants can actually come online. That's what you're seeing through the ARIS proposal and through the RRI and those. That's kind of that, I hate to use the term Band-Aid, but I'm not sure what else to call it. That's that interim fix until you have time to develop and deploy those new resources that are going to be of the larger variety that I think we would all agree are going to be needed on the system. So you are seeing responses to the price signals. It's probably not as fast as some would like. It's probably not in the volume that some would like, but you are seeing the response. You're seeing decisions be made based on the signals that are being offered. And maybe not quite as extreme as Bill's description, but I would agree if PJM could figure out how to get this back on track and have auctions that are actually on schedule again, that would go a really long way towards firming up those price signals and making it very clear what actions are needed, whether you're a utility or whether you're a competitive wholesale power generator.
Thank you. I'm going to ask just one more follow-up question before we move on to the AI and the large load growth and all the really interesting challenges that we have on the horizon. Is we spent a lot of time talking about the generation. And Todd, you made a great comment about separating the engineering from the politics. And I am an engineer. My friends call me a quasi-engineer. But in this case, I will stick up for the politicians and the energy policy makers because they do have constituents that are looking for a greener decarbonized grid. There are states with renewable targets and mandates, and we talk about bringing these resources on, but how do we marry that with states that do want to have certain goals by 2030, 2035, 2040? And anyone could jump in. That's not to pick on Mr. Snitchler. You can go first.
I'll take first bite, and then I'll let the experts say what they think. I think you are starting to have the dose of reality that has perhaps been needed for a while. When you have a 30% reserve margin and no load growth, you can make a lot of state policies that have almost no impact on the system's operation. When you have load growth and a tighter reserve margin, the costs are felt immediately, and state policy choices are starting to bite. And I think consumers are saying, well, I don't think that's what I signed up for. I was looking for free or less expensive, and they're seeing that it's not free and it's actually more expensive. And that is forcing the political class to have to say, well, we still aspire to these goals and aspirational goals. There's something wrong with those, but they've got to be connected to system operational realities. And if you're going to jeopardize operational reality by trying to achieve arbitrary goal with a certain percent by a certain time because it's great for a bumper sticker, that's good for electioneering, but it's not good for system operations. And I think we have reached the point now where policymakers, even in some of those more aggressive states, are having to say, we still want to achieve these outcomes, but maybe 2030 is not the year. Maybe it's 2040, or it's some point in the future, or it's nondescript. But I think the reality of load growth and declining supply has made the price impacts tangible, and that is forcing changes in consumer response, which will ultimately lead to a change in elected officials' response.
And I would add to Todd's point on the system reliability aspect of this, and it's really a matter of physics in that I think that the system has gotten out of balance with regards to having enough rotating iron on the system that's meaningful. When you look at how much we pushed on the renewable side and the retirements of the big generators really has put our ability to manage voltage and VARs in the system, so to speak, in a much more delicate position. And so while we certainly continue to look at renewables as an asset, we have to make sure the system is able to operate. And to do that, we need to add large rotating iron to the system, and we need to do it pretty quickly. And I think it goes to Todd's point where there's certainly cost issues on the renewable side. And I know, for instance, in Virginia, the Clean Energy Act here is being challenged now because of the cost of the renewables to meet all that and such. But as we think about that, we still have to operate the system reliably. And to do that, we have to take account of the physics of the matter.
So maybe even to simplify that further, again, going back to a prior rule would be, no one really wanted to talk about natural gas, right? It was almost a bad word to talk about natural gas if you were also talking about decarbonization. And I think the kind of the non-engineering way to explain what Bill was just saying is you need a certain amount of generation, baseload dispatchable generation to make room for those renewables, those intermittent resources in the system. And I think that kind of view on incrementalism and having some balance. I'm actually hoping that we can get back there, because the pendulum kind of swings both ways, because I think kind of the pendulum swinging the other way, saying, you know, no renewables and intermittent resources are terrible and forget battery storage. Like, that's also not the right answer, right? I'll go back to kind of where I started, which is every technology, every resource has a place. You need to use it and integrate it into the system in its intended space. And some of these resources are complementary. Battery storage and renewables. I would say natural gas generation and renewables. Those are actually complementary resources to do what Bill talked about. It also makes room in your system. And so there's a lot of outcry, right, about the 90-day orders in the coal plants. You know, Eddystone is not in our service territory, and it's in Pecos. But those plants running, or Brandon Shores running in Maryland, we are in an unprecedented time in terms of load, but all that data center load's not on the system. These are current system issues, and I think those are kind of perhaps the unintended consequences of policy making that is really extreme, or a little too reliant on maybe a slogan without kind of the actual engineering innovation to back it up. I think, again, we can go further, we can innovate, but it's how fast can you go? Where's the appropriate place? Not every jurisdiction has to look exactly like the others, right? So again, I think it's just kind of a system view, but I think we've kind of pendulum swung a little too far. Now it's coming back, and hopefully, when we through collaboration and I think what's going to need to be a broader grid build out, we can get to a more balanced place.
Thank you. And now we're going to jump into the large loads and the data centers. And Todd already touched on it about the forecasting. And we will get back into the natural gas in just a couple of minutes. So it's very exciting. We actually have another CEO in the crowd from Artex Oil, so he's very excited that we'll be talking about natural gas interdependencies. But regarding the large loads in the data centers, all the forecasts suggest we're going to have this unprecedented load growth. We've touched on that. But how do we manage that? And here are the things that we're reading and seeing, is that you hear about these concepts. When I was at the old Buckeye State at Ohio State, the #1 team in the country, we used to talk about BYOB, about bringing your own beverages. But now what we hear about is BYOG, bring your own generation. We've also heard about Beyonce, which is bring your own new clean energy, of a data center bringing an SMR or bringing a nuclear power plant with no carbon emissions. And Joe, this is where you could jump in as well, because we hear things about co-location. At first it was the load was behind the meter. Now it's the generations behind the meter. Now it's, well, we'll just do a purchase power agreement, and that these data centers that want to go fast and they want to go big with these big megawatts, are they going to be competing in the same supply chain as us? Where are they getting their turbines from? So there's a lot to unpack here with the large loads and the data centers. Bill, I'll start with you. Columbus is somewhat of an epicenter of this. We have Loudonville County in Virginia. Columbus is the next epicenter. We also have Dallas, amongst other areas, where we're seeing this massive data center load growth. And what are your perspectives on this?
So AEP, well, first of all, the Ohio State University really bugs me. I'm a Nebraska Cornhusker and proud of it. But they can, but they win, so it's hard to argue against them. But I do have a Nebraska hat on my Zoom calls right on my shoulder, just so people know. So AEP recognized the large load issue fairly early on, and in fact, started a large load tariff in the state of Ohio that was very focused on data center load to protect all the rest of our customers. And that tariff in Ohio has been approved. It's in place. And essentially, in a nutshell, it forces the data centers to pay up for all of the incremental costs that it's going to take for them to get connected into the grid. That idea actually spread across many of our other states. We now have similar tariffs in Indiana, West Virginia, Kentucky. And in those states, it's not limited to data centers. It's actually a large load tariff, but very similar in design to what we have in Ohio. In Ohio, we are swamped with data center load coming on. And I agree with Todd that not all of this load is going to show up across the United States, and that if it does show up, it may not show up in the amount or as fast. But in our states, we have signed agreements, as I said, for 24,000 megawatts, and that's predominantly data center load that's coming on. And so depending on what state we're in Ohio, obviously we're wires only, and we depend upon Todd's organization to bring the generation that is needed and to work in collaboration to try and meet the demand that we have there. But this is a significant issue for us, and it's really forcing us to work differently with our regulators and our states to try to find a way to more quickly add generation. This is a point in time where we have to recreate the rules, recreate the vision, and do things that have not been done in the past in order to accelerate what we need to do. But we have to do it in a way that doesn't impact our existing customers and ensure that those who create the cost pay for the cost. And in doing such, there was a lot of discussion around the fact that if these tariffs go into place, the load's going to go away. And just the opposite has happened. We've actually had increased requests for connection into our system, particularly in Ohio and in Indiana. And so I think, again, we have to think very creatively about how to get past the hurdles that we have in front of us, put in place things that maybe appear to not be popular and can stunt some of this growth, but in fact actually accelerates it going forward. And so again, our focus is to figure out how to work with all of the parties to get the generation in and the transmission in as quickly as humanly possible.
Thank you, Bill. Joe, if a data center wants to bring its own generation, or we have these kind of, like I call them, these hybrid configurations, what are your thoughts on operational and security challenges there?
Well, the data centers, I mean, they're large loads because they can have an impact on the reliability of the bulk power system. In and of themselves, they have that ability. They can destabilize the bulk power system. At the same time, it goes back to something Christine said, 24/7 service. They need 24/7 service. So they're large loads with an unprecedented, at that level, an unprecedented requirement for power quality. But in and of itself, that presents an opportunity as well. And so there are companies, I won't name names because we don't endorse or disparage anyone's products, but we have had conversations with the BESS folks, and for about 1% the cost of the data center, you can add the service that you've got a battery matching system that not only mitigates the voltage and frequency perturbations, but also then eases the impact, the other impacts, the loss of load, for example, on the bulk power system itself. Now, this is all in the context, back to Bill's point about less iron in the ground. We've got lower system inertia, and we've got worsening frequency response characteristics, and we can expect that trend to continue. And so at the same time, we've got higher load levels with more stringent requirements for power quality. So matching that up with a BESS may not be an option. It may come as a part of service, and the BES systems, by the way, an optimal arrangement is for the utilities to own and operate those systems. And so they can have that assurance that those systems will remain at the ready. One other additional consideration is that the batteries themselves need to be charged at about half level. So they can not only act as a source, but they can also act as a sink should that facility be lost. So I guess what I'd like to say is that rather than its own generation source every time, there are requirements that can and should be considered to be able to mitigate the impacts of these large loads on the grid.
I think what I would add is we're not at the very beginning, but we're still in the early stages of how this is going to resolve itself. And I think all tools in the toolbox have to be available. So behind the meter, yes. In front of the meter, yes. PPAs where there's a bring your own generation and somehow that's configured, yes. All of those, I think, have to be looked at, evaluated, and a pathway determined for us to find the best, most expedient way to get there. Because if we think we're going to have one perfect way and try and apply it everywhere, that's very unlikely to work everywhere. I've overused the phrase, there's no silver bullet. In fact, there's probably not even silver buckshot. So we've got to look at the various approaches that can be taken because it may work in some service territories and it may not work in others. And we may find a pathway that enables rapid deployment in one jurisdiction where another jurisdiction doesn't favor that type of approach. So I think we've got to keep all cards on the table, at least which is appropriate given where we are. I think we have to keep the cards on the table while we're figuring out what the appropriate way forward is. But I think it's also, there's an opportunity to come back to some of the things that we probably have known but have not utilized, which there's no prohibition on bilateral contracts. If the largest balance sheets on earth want power faster and they want to get connected faster, they have the wherewithal to figure out how to contract for that, whether it's buying it through an independent power producer, whether it's sorting out, they want to become a power plant owner and developer. Spoiler alert, they don't. They want other people to do that because they're good at what they do. So we ought to be looking at what are those various approaches that maybe we've not had to think about for the last 15 or 20 years because we didn't need to. But now you're dealing with not one steel plant, you're dealing with 50 or 100 data centers that have as large or larger loads than that one steel plant would have had 30 or 40 years ago. And so how we think about that is some of that innovation that we're going to have to think about. It is some of the ways we're going to look at various approaches to try and deploy quicker. I made the comment last night, I'm probably not supposed to say it, but I'll say it anyway. We may have to break a few eggs to make the omelet. I know there are parties that probably would be upset if people bring their generation and get moved to the front of the queue. I'm not endorsing it, but I'm suggesting that that's a discussion that ought to be had. Because if we need to move faster, to Joe's point about winning the AI war and being ahead of China and the rest of the world, then there are going to have to be choices that are made, and they're not easy choices. But we've got to think about how we do that in a way that ensures reliability, helps mitigate cost, and ensures that we can succeed in delivering the outcomes that policymakers say that they want. So I think it's an all hands, all approaches position to start from until we figure out with some experience exactly what works best. And I mean, Bill noted they've put a tariff together that seems to have gotten traction in a number of jurisdictions. That's one approach. There are other approaches that probably will work in other jurisdictions, but I think that's indicative of how we need to be thinking about a wide set of solutions instead of trying to narrow down one at the early stages and say, well, this is how everybody has to do it. Let's shoehorn that into the same solution set. That probably is likely to fail.
Thank you, Todd. So the ERO enterprise also endorses this any and all solutions. However, I do want to ask a follow-up question to Bill and Christine, because in your line of work, you have control room operators. And as we add more complexity and things are behind the meter, or these are my megawatts, but not your megawatts, and I have batteries that are half charged or 25% charged. I came from a control room environment. I was in there for about 7 years. What are your thoughts regarding, adding risk to the system regarding operators having to make decisions where they have some visibility, some things are beyond their visibility, not knowing how things may interact or react on a given day based on a fault, a day ahead study? What are your worries from a control room perspective, knowing your operators have to operate in this new hyper complex world?
Yeah, let me start now. Actually, I'll actually start at the behind the meter, because we did have an arrangement in our service territory that started as a behind the meter arrangement and got a lot of attention at FERC and PJM. And look, while we as the utility were working with that from a contracting standpoint, we took a pretty hard line position from a transmission operator standpoint. And if you want to be disconnected from the grid, like, you need to be disconnected from the grid. I'll use Todd's kind of little bit pregnant reference, right? It really causes a lot of challenges for grid operators, reliability, resiliency, and also cost allocation for customers. So we are generally proponents for a front of meter approach. All of the gigawatts that I mentioned in our service territory our front of meter. Generally, we're finding that there's and that doesn't mean not having co-located generation, right? Because there are benefits to that in terms of the infrastructure build, kind of availability of deliverable generation close to the source. But front of meter gives us that visibility. It generally, from a reliability and resiliency standpoint, there are benefits, including the socialized interconnection upgrades that need to be made for the connection of that large load onto our system. And from our approach and discussions with hyperscalers, they want that kind of reliability, and that we can provide them on our transmission system. Similar to Bill, we do have contracting provisions. It's not a tariff yet, but we do have electric service agreements that lay out the minimum load and payment requirements such that those large loads are paying for the upgrades, the socialized upgrades on our system. Whether they are ultimately taking that full load or not, they're making a commitment to pay. Let me just kind of jump with your question from like transmission and distribution, right? Because I know that generally we're talking kind of wholesale transmission, but this is also applicable at the distribution level. We actually, PPL Electric Utilities has had a pilot for 3 years, a DR management pilot, really kind of looking at this as more of a distribution system operator platform, but it's giving us visibility into DER on a limited basis. It's thousands of devices now, but it's giving us visibility into those devices on our distribution system. There are required inverters they need to install, and then we have a communications device that the utility owns. That has not only unlocked hosting capacity of the system, but it's enabled us to not back down a generator, but to monitor the volt bar on the system. It's something that, from a reliability and resiliency standpoint, actually you can have those DER devices actually providing benefit instead of detracting from that system. I will say, from a system operator standpoint, both transmission and distribution, it is a real challenge if you've got interconnections into your system, or in the case of behind the meter, something that really isn't interconnected into your system or shouldn't be actually drawing. And we had that situation, that emergency situation at the transmission level, which led us to take a harder line on that behind the meter project, which ultimately moved front of meter. But it is a concern. But again, I think it's, in some ways, it is as much a concern at the distribution level with the number of devices that we have on the distribution level as it is on the transmission level.
Yeah, to answer the question directly on the control room matters, first and foremost, again, in partnership with Jim Robb and his team and the NERC certification of operators, obviously that is comprehensive and fundamental to our overall operations, and that will continue to advance as matters on the system change. But then I personally hold our operators accountable to make sure they understand the system and that they're ready and able to take the actions necessary to protect the grid. That's their fundamental job. And as we're adding the level of data centers and crypto to the grid, our designers are now beginning to enforce breakers for those so that we can actively trip those units off if we need to, or move them to their backup generation if in fact there's a system requirement. And so for us, it's looking at this in a more collective manner. We have across our system all varieties of behind the meter, front of the meter, both in and out. So we have to make sure we understand how to do all of it. There is a concern around data centers collectively coming on and off that could significantly impact the grid. Our operators are aware of that and focused on that, and make sure that we have the capability, again, to first and foremost keep the grid reliable and protect the grid while we're going through our normal operational training.
Thank you. We're going to skip over the essential reliability services question because, Todd, you did an excellent job describing the physics and what's needed. For anyone who's interested in reports like that, MISO has an RIIA report that talks about the physics needed to operate a grid and at what levels of IBR penetration you could have certain challenges and such, and how batteries can help with the fast frequency response and how all those things work. But I do want to leave enough time because Christine did bring up, the natural gas discussion. And like I said, we have another CEO in the audience today from Artex Oil. Natural gas is often cited as the bridge energy fuel that's going to be the bridge to whatever the future holds, whether it's that 2040 or earlier or later. However, there are natural gas interdependencies that we're concerned about. There's questions, do we have enough natural gas pipeline infrastructure? Do we have enough natural gas pipeline storage for both winter peak and even summer peak? Because what I've heard is that at times natural gas power plants or natural gas compressors, they may have maintenance outages over the summer. And Joe, this is an opportunity for you to chime in as well, because even if we do an excellent job securing our systems, our control centers, our lines, our substations, our critical assets, there are security challenges regarding our natural gas infrastructure. And what does the future hold? Are we going to tie the pipelines together and operate it like how we operate the grid? How do we protect these things? So I know that's a loaded question, but I think this is a really important topic that NERC has been looking at. We've been writing white papers on it, so I'm interested in your thoughts. And anyone could jump in. This is the question for Paul Siegel, so anyone could jump in.
Well, I'll start. I don't actually consider natural gas to be a bridge fuel. I consider natural gas to be a fundamental energy provider for this country, and I think it's going to be here for a very, very, very long time. Our strategies around it will have to change if and when we can add more pipelines. That'll be critical. Otherwise, we'll look for sites to build on top of reserves and minimize the pipe needed. There's only so much gas that can go through these facilities, and clearly we have to be thinking differently about it. But at least for me, it's a fundamental fuel. It's something that's in our strategy. It's something that we're going to continue to use for a very long time. And that said, we know that pipelines are critical assets and need to be heavily secured. And I know Joe's focused on that, so I'll toss it to him, and you can talk a little bit about the security aspects.
Thank you, Bill. I think so. If you look at the numbers, EIA said that currently we have 40% of our electric generation on natural gas pipelines. Much of that natural gas is interruptible or non-firm. That's become single source fuel dependency. We have tens of thousands of megawatts of generation on single natural gas pipelines. Our adversaries are well aware of that, and they target those pipelines. They plan for those attacks. In fact, CISA released, and I have to be very careful, so I'm going to read this to you, but CISA released a bulletin called Chinese Gas Pipeline Intrusion Campaign from 2011 to 2013. So many years ago, the Chinese were aware of our dependency on these natural gas pipelines and began targeting. Here's the specific quote. Overall, the U.S. government identified and tracked 23 U.S. natural gas pipeline operators targeted from 2011 to 2013 in this spearfishing and intrusion campaign. Of the known targeted entities, 13 were confirmed compromises. 13 were confirmed compromises. 3 were near misses, and 7 had an unknown depth of intrusion. Now, the reason why they're unknown is because they probably didn't give the information to DHS. So we don't know what happened with those. The U.S. government has attributed this activity to Chinese state-sponsored actors. CISA and FBI assessed that these actors were specifically targeting U.S. pipeline infrastructure, get this part, folks, for the purpose of holding U.S. pipeline infrastructure at risk. This was not economic targeting. This was pre-positioning in order to be certain that the Chinese could embed themselves in the control systems, and at the time of their choosing, they could take those pipelines down. Additionally, CISA and the FBI assessed that this activity was ultimately intended to help China develop cyber attack capabilities against U.S. pipelines to physically damage pipelines or disrupt pipeline operations. So, normally I have a slide and I talk about all the bad actors. So there are 4 adversarial nation states that DNI, Director of National Intelligence, who we worked with very closely, Director of National Intelligence names. That would be China, Russia, North Korea, and Iran. And don't underestimate the capability of any of those countries. So I said that to say this: we're moving towards single source fuel dependency for dispatchable and baseload generation. We're buying non-firm gas from these pipelines. We know our adversaries are targeting effectively, have been able to effectively target the control systems on these natural gas pipelines. And therefore, it's critical for engagement, both your engagement with the gas utilities that supply fuel to your generators, as well as our engagement. Natural gas pipelines are one of the areas of FERC jurisdiction. Our office works across all the areas. So we have the interstate transmission system, which includes the bulk power system. It is a subset of the interstate transmission system, LNG terminals, oil and natural gas pipelines, and hydroelectric facilities. However, as with anything else in the government, it's confusing and sometimes mixed. There's mixed authority. And so TSA has the primary authority for the cybersecurity of the natural gas pipelines. And you bet we're working very closely with TSA. So we facilitate architectural assessments, IT/OT network assessments. We identify vulnerabilities in those networks that we know can and have been exploited. And then we work with the individual owners and operators of the pipelines. But when you think about how critically dependent your utilities are, the next question is, what have you been doing? How have you been engaging with the natural gas utilities that supply the service? With that happy note, I'll turn it to Todd.
Wow, that's tough to follow up. So I will say that on the generator side, we have tried to sort through some of the challenges on the interplay between gas and electric. And so we partnered with INGA, the Pipeline Trade Association, and the Natural Gas Supply Association in forming the Reliability Alliance after Winter Storm Elliott to say that was a near-miss situation that should never have happened. What do we as industry need to do in order to better ensure that there is alignment between the gas sector, the electric sector? What can not the trade associations do, but what can the members that actually sit at the desks, buy gas, have to make the transactions with the gas suppliers, and ultimately are the ones who are trying to navigate this single point of failure or the interruptible service contracts, or they're really all interruptible because if a force majeure is called, guess what? They're going to cut off your gas. So even firm supply is not perfect. We tried to figure out what are some of the things that can be done to improve and draw the two industries closer together, because they are more interdependent than they have ever been, because, as Joe notes, so much of the supply is now being produced via natural gas generation. And so we provided a report. We've taken it to FERC. We've shared it with NERC and Jim Robb and his team, and we have tried to figure out ways that we can greater, as industry, without a mandate, but as industry, try to draw the industries closer together. If you've asked if we resolved the misalignment between the gas day and the electric day, we haven't. That probably is one of the issues that will be last to survive because nobody wants to talk about that. But what are the practical day-to-day situations that can be resolved? And I think we've made progress. And I say that because we've had a couple of other winter events since Winter Storm Elliott where the system performed dramatically better. You didn't hear about it because there was no near miss, which is exactly how it should work. You should expect the system to operate that way. And I think it also involved the RTOs operating with a little greater line of sight into the information, being a little more conservative about how they're dispatching and ordering plants to procure supply, because that's the way to get it. If you ask an entity on Saturday to buy gas for Monday when all the gas was sold on Friday, there's no gas to buy at any price. That's not going to be helpful. So we've tried to think about navigating through some of those challenges in a way that helps the system operate more efficiently. There is a cost associated with it. We can't ignore there is the cost of uplift. But my first career was in the insurance world. And you know what? Insurance comes at a price, but it also is what you need in order to make sure that you can have your home replaced in the event of a fire or that your car is replaced in the event of an accident. It's the same type of concept that has to be thought about when you're ensuring the system is reliable. There might be a cost to it, but the cost of the system going down is an order of magnitude or more larger than that uplift cost. And so we've tried to think practically about that. Brian, I thought we were going to do rapid fire. Do we need more gas? Yes. Do we need more pipelines? Yes. Do we need infrastructure sooner? Yes. All those things are yes. And that's where the permitting and siting issue at both the state and federal level has actually got to address these issues. I know we love to talk about the issue, but we actually need to get solutions implemented, or we are never going to get ahead of where we need to be. And to Bill and Christine's point, load is coming. And it's going to require more gas, and we're going to need more pipelines because many of the pipelines are fully subscribed. There is no more capacity to be gotten. The only way you're going to move molecules is with new pipe capacity. And so all of those things are true, and they all have to be addressed quickly.
Thank you. So we're going to, our last discussion topic before we head over next door to lunch is we're going to talk a little bit more about cyber and physical security. And last night I couldn't sleep, and it wasn't because I had a heater at the casino. It's because I had dinner with Joe, and Joe was telling me about all the risks we're facing as a nation. And then I was up all night thinking about what are we going to do? And how can we solve these in the next, 15 minutes, really? So Joe, we'll start with you. And what are these security risks? We've talked a lot about the AI arms race, and what does that even mean? What does that look like? What does that mean beating China in the AI arms race? And what is this a race towards and for and to? And what are we up against? And how bad is it?
Okay, so it's bad. It's really bad. So, but it's very solvable, folks. It's very solvable. So I'll start with something real quick, then I'm going to jump over to AI just for a moment. So who's heard of the Davidson window? Does anyone know what the Davidson window is? Anyone that wasn't at dinner with me last night, I should say. Okay, so the Davidson window, you've heard it, I'm sure, but you haven't heard it phrased in that way. Admiral Davidson was called before Congress. He was pressed by Congress. I've been in that circumstance. He had to give an answer, so he gave an answer. And the question was, how soon will the Chinese attack Taiwan? When will that occur? This was in 2021, and Admiral Davidson said 6 years. And they said, why 6 years? He said, it's the 100th year anniversary of the People's Liberation Army. Now, that's significant, could be significant for us, because has anyone heard of Unrestricted Warfare, the book? Okay, so good, very good. We got one. That's really good for an audience, way more than I usually get. So Unrestricted Warfare was an assignment by two Chinese colonels by the People's Liberation Army. And what they said was the United States is far superior multiple ways. How can we beat them in an all-out engagement within 10 years? This was 1998. The result of their work was the basis for unrestricted warfare. So they wrote this plan, and it was a classified document. It was scooped up by the Defense Intelligence Agency. Way to go, DIA. It was translated, declassified, and released for print. You should look at the book. It's a terrible read because it's got all these language things in it. But the bottom line is it's a multiple front initiative. Everything from making drugs and shipping them into the United States to harm our population to, on page 123, burying a cyber virus in the U.S. power grid so at the appropriate time, and that time would be when they attack Taiwan, you can bring down the U.S. power grid, especially in the urban areas, cause chaos, distract the DOD. They'll have to deploy troops, and then they'll be too distracted and spread out to effectively respond to the attack on Taiwan. Now, everything coupled together, it goes to something Bill said before, we may have a year and a half. Maybe we don't, maybe it's longer. We don't know. I can neither confirm nor deny that we have a year and a half. But what that would mean is that we've got some time to prep. So what's their targeting look like? What sort of TTPs are they using? What sort of procedures and tactics and tools are they deploying? And what are they targeting? So here's the bottom line, folks, for the audience. And I usually, when I give a talk, it's usually an hour, 2 hours. People leave. They get upset. They argue with me later. But the bottom line is just 3 questions. Now, ask yourself these questions. If you can't say yes to these 3 questions, you got a problem. Number 1, do you know what the adversaries, I'm talking nation-state adversaries like China, do you know how they're targeting and compromising your systems? You can't fix, you can't protect against what you don't know. You have to know that. Now, much of that information is classified. Who has security clearances? And of those that have the security clearances, I'll look down the table, how effective have those engagements been? Have they told you specifically about facilities that are being targeted and what they're doing, what the Chinese, for instance, are doing to get into those?
That's classified.
Right. Second question, do you know which facilities they're targeting? Yeah, when we have discussions with the Pentagon, we have great subject matter experts. We work with every agency. We're talking with the generals at the Pentagon. A question can be, hey, how about a power outage? And the question back would be two questions. How big do you want the power outage to be, and how long do you want it to last? That's the question. So the question is, it depends on your most significant facilities. What are the facilities that, if lost, are going to trigger under-frequency load shedding, for example? And in the context of this discussion, it's critically important. Less iron in the ground, less facilities that trip you under-frequency load shedding, UFLS. And then the third question, so the second question is, do you know what to do to protect against those threats? So number one, do you know what they're doing? Number two, do you know what best practices you can deploy? Usually it's a 20-80 or 10-90. 10% of the effort gets you 90% of the results. It's not that bad. It's not that hard, folks. You just want to push them off target. That's all. And there's a whole separate discussion on physical security we can have, but we won't, because I want to leave time for everyone else, even though I probably just used up all the time. And then the third question is, do you know what facilities to protect? You know, what's your most important information? It may not be what you think. It could be personnel information. Adversaries love to know who the key operators are, who holds the keys to the kingdom, and those are the folks they're going to go after. So anyway, it goes to those three questions. I'll stop there. Got lots of other information, but we'll put a pause on it there for the next round or for the next panelists.
Todd, Bill, Christine, anything to add on in the security conversation?
Aside from, I'm afraid they're going to take my shoelaces and my belt after Joe talks. I think Joe's correct. And I think it is some comfort to know that the industry has a very good working relationship with our federal partners on issues around security. I won't comment about Joe's rhetorical, but not rhetorical question about, is the information always useful and actionable and timely? I think there has been a concerted effort to try and ensure that it is more of all of those. And I think that has been successful. I think it will continue to need to be important. This is one of the issues that I think all of the industry has taken very seriously and is working very diligently. I'm looking at Bill's Reddy, who works for me, and the Grid X exercise is coming up in November. Grid X is something that if you're not already participating, and I know everybody at this table does, but you should be, because it's an opportunity to see how you respond under pressure to a theoretical threat environment that is put together by the organizers of the day in an effort to try and make systems break. That's the whole objective. How do you respond in situations that could be the real life situations that Joe has mentioned? And so those are not just great tabletop exercises and an opportunity to see your peers, though that is one of the benefits, but it's an opportunity to really see, what do you do? To Joe's questions, what do I do when the communication system is broken down and I can't communicate across my footprint? What's our backup plan? Have we thought about some of these things in an effort to know what we don't know, to know how we'll respond, and then to appreciate what may be a targeted environment? And you know, each individual company knows where those are. That information is classified and shared with them. But I think those are all pieces and parts of how the industry is trying to not just be responsive, but get ahead of some of these challenges, because to Joe's point, it's the classic terrorism problem, right? They only have to be right once. We have to be right every other time. Those odds are not favorable to the side of the defender, but that's what the entire industry is trying to achieve.
Sorry, I just want to add on just very quickly to that. This also changing landscape. It's moving much more rapidly now. Again, it's a convergence of AI, quantum computing, and big data. And so now what you're seeing is one of the stats I had for you today is that about 20% of the compromises now, using toolkits and automation, hackers are able to exfiltrate information within an hour, within 1 hour. Now, I want you to think about what happens when we bring AI to bear. We just finished up an exercise in Virginia called Cyber Fortress. I'm not sure if anyone was at that exercise, but we had National Guardsmen attacking simulated utility networks. In that exercise, we captured every action, every attack vector from the Guardsmen. We had Red Team Guardsmen attacking systems. We had the utility defenders as well as National Guardsmen defending every reaction that they had. Over the course of several days, we fed that into the AI program that we're working with. And that exercise, that AI exercise, completed every simulated attack and response within about 1.5 seconds. So you can see we're moving now to machine warfare. So we got to get the fundamentals right now to prepare for what's coming very rapidly.
Just one thing that I'd add, and Todd and Joe covered it really well: the defense in depth, the collaboration, the not just the kind of the if, but the when, and how quickly you can identify and recover. But I would just add, we also know one of the biggest vulnerabilities or ways in is through our employees, right? Those that are just, and it's not just our system operators, right? It's anyone. And so, still a really continued focus on our training, our phishing campaigns, our corrective actions with employees. It's something that we are drilling constantly. I think many of us at PPL live in fear of the email that you will fail, because they come often, and our folks are getting much more sophisticated in what they're sending to us. But I'll tell you, I've sent a number of kind of phishing emails that were justifiable phishing emails. Now, sometimes maybe it's just a spam for my credit card, but you never know when it's the one that is what you described, Joe.
Right. And I just want to follow up with that very quickly. Christine, Bill, did you want to?
Well, just one thing on phishing, and Christine's exactly right. Our best defense are our employees, and our biggest risk is our employees.
Yeah.
And so, at least at our company, we have a safe and secure culture, not only safety of our employees, but security of our employees, security of our system. But it's also a matter of performance, in that if you click on 3 phishing emails in a 12-month period, you're fired. And so we have a pretty strong discipline around this, because it is the easiest way in. And Joe's drilled this into my head over 20 years, that we have to just continue to pick up the discipline, pick up the culture of a secure system and a secure operation. And to do that, you have to get into the hearts and minds of the employees.
Thank you, Bill. Just real quick, too, I want to demonstrate something with just a few stats, but just a second, Brian. So think about phishing. We're getting better at phishing, though. So the number one exploit. So the first item is newly discovered vulnerabilities are exploited now at a record time. How fast do you think they're exploiting newly discovered vulnerabilities? So the manufacturer puts out a patch, says, hey, we have a CVE of 9 or 10. It's 4.76 days now. Okay, this is 43% faster than previously discovered. Think about your patch cycle. When you get a CVE of 10 and it's on your OT network, and we'll get that next week, you're definitely way over the average exploitation time. So think about that. Second statistic is for the fifth year in a row, exploitation of a vulnerability was the most frequently observed initial infection vector for organizations. So if you think about how quickly our adversaries are exploiting, and they've got automated processes, and they're going to use AI to bring these automated processes forward. So if you think about how fast they're exploiting, it makes sense to me that it's 33%. But this is very interesting in the context of the conversation. Stolen credentials now have overtaken email phishing as the second most frequently observed initial infection vector, representing 16% of the intrusions. So we're getting better at phishing, but are we shooting behind the rabbit? Our adversaries, when we get better at something, then they shift tactics. So are you watching these tactics, and especially the nation-state actors? If you operate critical facilities, are you watching these vectors, and are you adapting as well?
Thank you. Every time Joe says really quick, I get more and more terrified. A shameless plug, you don't have to wait every 2 years for GridX, although please do also wait every 2 years for GridX. Dave Zapata, raise your hand. Lou, raise your hand. Anytime you want to work with Reliability First, we do custom tabletops. Those are free. You're welcome to engage with us. We'd work with you on any scenarios. We could do custom scenarios. We'd be happy to help you with your security protocols. So in about 13 minutes, we have a beautiful plated lunch in Salon A, which is directly ahead of me. We're going to be hearing from, CEO and President Jim Robb of NERC, and then also FERC Chairman David Rosner. However, before we convene for lunch, I'll give you all parting words to our audience. We have a very diverse audience today. We have legislators here. We have commissioners here. We have primary compliance contacts. We have attorneys, engineers, and everyone in between, reliability and security. What parting words do you have for them regarding what they can do and what is their role in helping us build, operate, defend this grid of the future? And Christine, we'll start with you and we can work down the line.
Sure. I think, look, if you didn't get this from this panel, right, reliability, resiliency is paramount, and we need to make sure that we are doing everything we can to not compromise that, and to have collaboration and policies in place that are well thought out and moving us in that direction. I would also just add, particularly as policymakers and regulators, is keeping the customer at the forefront. And, what we're doing, what we're all talking about today is, at the end of the day, is to serve our customers, our large load customers, our residential customers, our small C&I, our retailers, all of them. And so sometimes I think when we start to get too kind of far away from that, we kind of lose sight of what we are here to do and what you're here to deliver. And so I would just say, reliability is paramount, and keep the customer focused.
Really nothing to add to that. I think that's a great summary. I would just say that we have to be creative. We can't get to where we need to be following the existing old rules. And so as we look for ways to accelerate what we need to do, we all have to think differently so that we can bring the customer online as quick as we can.
Bill, that always makes me think of the Steve Jobs commercial, Think Different. If you haven't seen that commercial in 20 years, look it up. But I think that's exactly right. I think it's been captured pretty precisely that everyone agrees that reliability is paramount. It has to be first, and that change is already here. And so I think we all agree that we're going to have to think about how we try and address these challenges differently. And the opportunities are tremendous. I don't think we should lose sight of the positive side of this story, because the opportunities for generators are great. The opportunities for wires utilities are great. The opportunities for consumers are great, if we all collaborate and deliver the outcomes that consumers say they want. And I think we have to, sometimes it's easy to slip into the negative. I think we need to keep kind of a positive outlook about where we can go. And Joe's about to be the heavy that says, and we have to do that because security is paramount, and two things can be true.
Right. So thank you, Todd, for that introduction. So I would say that really reliability and security are inextricably linked. In today's day and age, we can't lose sight of either. They go hand in hand, or they don't go at all. And secondly, I will say I've been a little remiss. Our office was specifically stood up to work with the states, the tribes, the utility members. We do individual engagements. If you're interested in assistance, we do that. It has nothing to do with compliance and enforcement, NERC reliability standards. This is all nation-state review of your utility networks to determine, identify, and prioritize vulnerabilities with you. So we do that at no cost. We'll send teams out. We do that on both the cyber and the physical security side. We do have special ops folks, people that actually train the special forces. They'll come out. They'll take a look at the physical security measures you have as well. So we'll stand by. We'll help you with it. But again, don't be intimidated. We're up against significant adversaries, but we can beat them. 10% gets you 90%. We can push them off target. We have a year and a half. If the Davidson window means anything, and I don't know that it does, but if it does mean anything, we've got time to be able to work together on this, and it'll take us both together to solve the issue. Thank you.
Please join me in a round of applause for our distinguished panelists.